Welcome back to All This Math. This is Professor Parker. Make sure you are subscribed to the All This Math YouTube channel. Make sure you like, comment, share, whatever, you know. Tell people about what we're doing in All This Math. Before we get into this lesson, today's video was brought to you by the ancestor, the late Frederick Douglass, abolitionist, statesman, orator, writer, responsible for recruiting a lot of black men into the Union Army so we could emancipate ourselves, during the Civil War. Don't let people tell you that Lincoln freed the slaves, like he was this great emancipator, when he in fact said that if he could have maintained the Union without ending slavery, then he wouldn't have ended slavery. Don't buy into that. Study and read. Speaking of Douglass, he wrote three autobiographies, three of them. His first one, Frederick Douglass, the narrative of the life of Frederick Douglass, an American slave. I don't know if that's the original title. Published in 1845. The second one, My Bondage and My Freedom. He had more to say. Published in 1855, 10 years later. Then, probably the magnum opus, the thickest autobiography, The Life and Times of Frederick Douglass, his early life as a slave, his escape from bondage, and his complete history, published in 1881. Three autobiographies. Plenty of information to learn not only about Douglass himself, but about the chattel slavery system, about American history, through the perspective of a person of African descent that was in the United States moving. You know what I mean? So definitely and don't just because Douglass is one of them people that we probably, if you're an adult watching this, you probably heard his name all the time every Black History Month, right? But did you really study him? Did you really learn about him? You know? So a lot of times people will make complaints and say, well, I'm sick of hearing about the same people for Black History Month. You hear about these people, but do you know these people? Have you studied these people? Right? We're adults. We can study. We can read. All right. You got to make time for that. All right. And if you do that, then that'll set an example for your children. Your children will want to study these people too. All right. So the books is out there. The books is available. Also, there's speeches. Probably his most famous speech that I'm aware of is his 1851 speech, the meaning of Fourth of July or the 4th of July to the Negro or to the slave. Because it's like, what are we celebrating? That's for y'all. Like, you know what I'm saying? We still enslaved. We in bondage. What you know what I'm saying? What's the celebration about? We not independent. You know what I'm saying? Y'all fought to get independence from King George in Great Britain so that y'all could keep all the money from slavery. And we still on the plantation as a result. So yeah, study Douglass. Definitely study Douglass. All right, now let's get into this. Now the reason that I'm doing this video and doing these problems is because your girl, Assata, my daughter, who I love and care about, who you see in some of these videos, my 12-year-old daughter, she took a quiz the other day in school. She didn't do too well. I wasn't too happy about that, right? But it's a teachable moment, and we're gonna learn from that. We're gonna learn from her mistakes, right? She took a quiz, and when I asked her what her grade she got, she said she got an 8 out of 11. So immediately, I'm a little alarmed. 8 out of 11 is not good. You know how I know that? Because I know off the top of my head that 8 out of 10 is an 80. 8 out of 10 is an 80%. And with fractions, the value of a fraction goes down when the denominator goes up. Remember that. The value of a fraction goes down when the value of the denominator increases. So 8 out of 10 is 80. So therefore, if you compare that to 8 out of 11, 8 out of 11 must be less than 80%, right? Because how do you convert a fraction into a percentage anyway? You first can convert it into a decimal, and then you convert the decimal into a percentage. Now let's try this. Let's convert 8 out of 11, because this is what I did with her. It's the exercise that I went through with her. I said, Assata, let's convert 8 out of 11 into a percentage. So to convert, first you convert it into a decimal. How do you do that? Divide the numerator by the denominator, right? Use a calculator for that. You don't got to do it manually on paper. 8 divided by 11 is 0.727272 repeated, right? Then you take that round, you can multiply that by 100 to get the percentage, which will be 72.72727272 repeating. Then I say to Assata, I say round that to a whole number. And because she knows that 7 is next to the 2, the 7, 5 and above, give it a shove. The 7 makes the 2 go up and become a 73. So your girl got a 73% on the quiz. I don't like that. I'm not too satisfied by that. Now, the reason she got these 3 questions wrong is because there were questions that look like this with the 3 numbers instead of 2. She's very proficient in adding and subtracting integers where you have two numbers, right? But when you introduce a third number, I think that she went all haywire, right? She wasn't as like open-minded. She didn't know how to like really figure out what to do. And I don't know how many examples like this she saw, right? So that's probably a part of the issue too. Before I go on, I want to make sure that everybody watching this video knows what an integer is, because we need to understand math vocabulary. Integers are a type of number, a number that does not have a decimal or a fraction component. 20 is an integer. Negative 14 is an integer. 1 is an integer, or negative 1 is an integer, right? 2/3 is not an integer. That's a fraction. 3.6 is not an integer. That has a decimal component to it. Negative 4.9 is not an integer because it has a decimal component to it, right? Integers do not have a decimal or fraction component to them. Now, somebody might make the argument, well, what about when you convert a whole number or an integer into a fraction? Don't you just make it into a fraction? Can't you make any integer into a fraction? Can I make negative 10 into a fraction? You can, by giving it a denominator of 1. So that's negative 10 over 1. But what happens when you simplify it? You get right back to negative 10. But what about 3/4? 3/4, you can't simplify 3/4 and convert it into a whole number or to an integer. It's not going to happen. It's never going to happen. So that's why 3/4 is not an integer, and that's why negative 10 would be an integer. Because even if you can make it look like a fraction, it still would convert right back nicely into an integer. All right, or into a whole number. Well, no, negative 10 is not a whole number. All right. So integers are all your natural numbers, meaning the numbers you were taught to count with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, keep on going, right? The number 0 and all the negative numbers that are opposite of all the natural numbers. So negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, right? All of those are the integers. So remember, if it's got a decimal or fraction component, it ain't an integer. This ain't that. All right? Keep that in mind. All right, now let's get into these problems. Because this video is really for Assata, right? It's for anybody that's watching, but it's for my daughter. So you see what I do? Like, I'm gonna make sure my kid's gonna be straight. But since I'm on YouTube, your kids can be straight too. Why my kids gonna be straight? Well, I'm tightening my kids up and getting my kids right. You can get your kids right too at the same time. We can be in this together. We're a team, right? So look, we got 5 examples up here. And what we do is, the way we break this down is we treat this kind of like 2 separate problems in one, each of these examples. So we subtract, right, with the first 2 numbers, right, 20 minus negative 14, right? And then we take that result and then we combine it with minus 1. And then we get our final result, right? So now, again, and also, math is a language. Math is a language. What happens when you see what's called a double negative? This is called a double negative. 2 minus signs, back to back. 2 minus signs, back to back. It's a double negative. A double negative is when you have 2 minus signs. That converts into a plus sign. It becomes an addition problem. 20 minus negative 14 becomes 20 plus 14. 2 wrongs make a right. 2 negatives make a positive. 2 wrongs make a right. 2 negatives make a positive. What's 20 plus 14? 34. Let's write that down. This part right here simplifies to 34. Then we got minus 1. Where'd the minus 1 come from? Right there, minus 1. Now we're just doing straight subtraction. 34 minus 1. Final answer, 33. Boom. All right. Now we're going to number 2. Look at number 2. 0 minus negative 16. Another double negative. Another double negative. What happens when you see a double negative? We treat it like addition. We treat it like addition. Both minus signs become 1 plus sign. Both minus signs become 1 plus sign. Both minus signs become 1 plus sign. 0 plus 16 is 16. Now, this is what I like. Look at this right here. Again, math is a language. You got to understand the language. What does 16 plus negative 3 mean? What does it mean when you add a negative? What does that mean? That means you're doing regular subtraction. You're doing regular subtraction. It's like when you eat junk food, right? You feel like, oh, I'm eating. I'm getting food, right? I'm getting sustenance. No, you're not. That's not nutritious. You're eating food. You're consuming food. You're adding food to your body, but it's negative food. It's harming you. It's harming you. And that's a note to self, because I eat a lot of junk sometimes, right? I got to remind myself, like, Kill, you got to chill. You got to eat better. Eat more healthy, more often, because you're adding a negative. You're adding a negative, so you're taking away from your health, right? So adding a negative is the same thing as doing regular subtraction. I call it regular subtraction. What's 16 minus 3? 13. Boom. Let's go to number 3. -6 plus -4. Oh, again, adding a negative, adding a negative, adding a negative. That's regular subtraction. -6 minus 4. -6 minus 4. Now, with a problem like this, I like to think of the number line. So imagine if you're a student watching this, imagine you're sitting in your classroom, and in your math class, your teacher probably has a number line taped on the wall above the smart board in the front of the class. If they don't, try to imagine a number line. Hopefully you know what a number line looks like, right? I got other videos on the channel that do use the number line to show how to add and subtract positive and negative integers. So you can check out one of those videos if you need help visualizing that. So -6, imagine I'm at -6 on the number line. That's my first number, right? And I'm subtracting 4. So when I subtract, I move to the left. I move to the left. Whenever you subtract on the number line, you move to the left. How far do you go? 4 spaces. 4 spaces. So from -6, you go -7, -8, -9, -10. 4 spaces. 4 spaces. So that's -10 plus 20 plus 20. Now what's -10 plus 20? Now what happens when you add on the number line? When you're on the number line and you add, you go in the right direction. You go that way. You go that way, right? How far? 20 spaces. Start at -10. Move to the right. 20 spaces. Starting point, direction, distance. Starting point, direction, distance. Starting point is -10. Your direction, because it's plus, means you move right. This is how far you go. So you're going to end up at +10. Did I need to write this plus sign? No. Why'd I write it? I just felt like it. It's my marker, my board. Felt like writing it. Do you need to write it? No. If you feel like writing it, you can. It's not going to be wrong. Notice I didn't write it with the 13 or the 33. Right? +10. Math language. All right, number 4. 15 plus -11. Again, language of math. What does plus and negative mean? The same thing as subtraction. The same thing as subtraction. 15 plus -11 is the same thing as 15 minus 11. Adding a negative is the same thing as regular subtraction. 15 minus 11 is 4. We got 4, and then we got minus -5. That's a double negative. That's a double negative. What's a double negative? What I tell y'all up here? What I tell y'all right there? Double negative is addition. That's the same thing as 4 plus 5. 4 plus 5 is 9. 4 plus 5 is 9. Last but not least, number 5, numero cinco. Start with 11 minus -7. That's a double negative again. Double negative right here. This was a double negative. That was a double negative. I keep referring back to these because as a student, what you have to learn how to do is look at your previous examples that look like the next examples, and then go back in your notes and say, okay, well, what did I do in the previous problem that looked like this? That's how you use your notes effectively. So this is a double negative. That was a double negative. This became addition. This was a double negative. This became addition. So this is a double negative. So this should become addition. The numbers change. The process stays the same. The game don't change. Only the players. 11 plus 7 is 18. Then we write plus 2. What's 18 plus 2? 20. Boom. So this is how you do it when you got multiple. Now, what if there had been 4 numbers? We would do the same thing. We would have did simplify the first 2, then combine that with the third, and then take the 33. If they had been 4 numbers, we'd have just did 33 plus whatever, or 33 minus whatever to get our final answer. That's all we would have did. That's all we would have did. If it had been 5 numbers, 6 numbers, 7 numbers, 8 numbers, 9, it don't matter. One step at a time. Simplify the first 2. Take that answer, combine it with the third. Take that answer, combine it with the fourth. Take that answer, combine it with the fifth. Take that answer, combine it with the sixth, and so on and so forth until you run out of numbers. All right. So this is the conversation I got to have with Assata. I got to make sure Assata knows how to do this. And yeah, we're gonna talk about this tomorrow. I'm gonna send her this video. Yeah, that's what I'm gonna do. She's gonna be annoyed. You know, she was a little upset because she didn't have homework tonight. But I found out about her quiz, and I'm like, sis, you need to practice. She was in her feelings a little bit, but she be all right. It's tough love. She needs that, right? So I sent her some practice problems. And she did them. She did them. Took a picture of her work, sent it to my phone. I looked over it. Yeah, I was satisfied. But that's our responsibility as parents, right? That's our responsibility. And also make sure you're checking over your child. If you're a parent watching this, parent, grandparent, uncle, aunt, make sure you're checking over your child's quizzes, tests, homework. Take a look over their work. Look over their work and let them know that you're gonna hold them accountable. Do your best to make time for that. Do your best to make time for that. Because if they know you're not gonna make time for it, then that removes some of the incentive for them to do it. And it's gonna pay dividends. Long term, it's gonna be worth you making a sacrifice and changing your schedule around and reprioritizing some things. It's gonna be worth it. I'm trying to tell you. All right. So as I was saying, study Douglas. Study Douglas. All right. Study that part of America, the part of American history that he was a part of. Look at his writing. There are a lot of biographies that have been written about Douglas, right? That can be studied as well. In addition to his 3 autobiographies, the man wrote 3 autobiographies. Most people don't write 1 autobiography or get a biography written about them. This man wrote 3 autobiographies, and I'm sure, and there's some biographies. There's been a bunch of biographies that's been written about him too, right? I know Shirley Graham Du Bois, Du Bois' second wife, wrote one about him. You know, she was a historian also, just like Du Bois was, right? And practice this. Make sure you know how to add, subtract, well, multiply and divide, but we didn't get into that in this video. Make sure you know how to add and subtract integers. Get some practice. All right. See y'all on the next video.